Okay, hi, my name is Diego and I hope you all are okay. And well, in this tutorial, we have our objective for this tutorial is for you to learn how what hydrocarbons are, how to name them, how to name cyclocarbons, everything. We hope you like this and find this entertaining. Thank you.
The increasingly large number of organic compounds identified with each passing day, together with the fact that many of these compounds are isomers of other compounds, requires that a systematic nomenclature system be developed. It is important to have rules on naming a hydrocarbon because each distinct compound has a unique molecular structure which can be designated by a structural formula. Each compound must be given a characteristic and a unique name. As organic chemistry grew and developed, many compounds were given tribal names which are now commonly used and recognized. Some examples are methane, butane, and acetone. The UPEC nomenclature system is a set of logical rules devised and used by organic chemists to circumvent problems caused by arbitrary nomenclature. Knowing these rules and giving a structural formula, one should be able to write a unique name for every distinct compound.
Hydrocarbons are organic chemical compounds that consist entirely of carbon and hydrogen. Each atom can form four bonds. These backbones include other elements such as hydrogen. The compounds are framed since two elements contained will combine easily with oxygen in the air, resisting energy. Fossil fuels such as oil and natural gas are naturally occurring mixtures of carbohydrates. The first side are with the prefixes. The first with met, and the second with ep, the third with pro, the fourth with pot, the fifth with pent, and the sixth with x, the seventh with ect. The first eight alkanes are: the first is methane, the second is ethane, the third is propane, the fourth is butane, the fifth is pentane, and the sixth is hexane. The seventh is heptane, and the eighth is octane. For in the second, we know that this is the chain and it's a chain. And in the third, we know we have 4 carbons and it's a butane. We also want
Okay, my name is Diego. I hope you all are okay. And well, in this tutorial, we'll learn how to name alkanes, alkenes, and alkynes. First, we'll start with alkanes. Alkanes, we have to remember that are identified by having just single bonds. And the steps for naming them are: number 1, find the longest chain of carbons. Number 2, circle each of the branches. Number 3, number the carbons of the main chain. Number 4, name each of the branches. Number 5, start writing with the location and the name of the branches. And number 6, finish with the name of the longest chain using correct prefix and endings. Okay, now let's practice with an example. I have here this example, and now we'll start to name it. We'll start with the first step. Find the longest chain of the carbons. We must count with the longest chain is, so here we see that 1, 2, 3, 4, 5, and 6. There are 6 carbons. But if we do 1, 2, 3, 4, 5, and 6, there are the same 6 carbons, and 1, 2, 3, 4, 5, and 6. They are also 6 carbons. So as it is the easiest one, we will choose this one, and we circle it. Now let's check the step number 2. Circle each of the branches. Now we have here our branches. Now let's go to the step number 3. Number the carbons of the main chain. Okay, for naming the carbons, we could start from left to right or from right to left. But we must start where the branches is nearest to one side. So we'll start from here. 1, 2, 3, 4, 5, and 6. Then name each of the branches. We have to name each of our branches depending on how many carbons they have. As they have just one carbon here, this will be methyl and methyl. And as this has 2 carbons, we'll put the name of ethyl. Okay, now start writing the name and the location and name of the branches. Okay, we'll start with the branches and with the location of the branches, but we have to start alphabetically. So we must start from the ethyl. And the location of the ethyl is in the 4th carbon. So 4 ethyl. Then we'll start with the other 2 branches, and their location are in the 2nd carbon, but we have to specify the location of both of them. So we put 2, 2, then the name part with the prefix of D, because we have to specify that they are 2 methyl. And then finish with the name of the longest chain. Okay, we have to put first the prefix depending on the number of carbons. So there X, and with the ending of our alkanes that they are N. So X N, and this is our name. Okay, and now let's see two more examples. Here, for example, I have 2,4,4 trimethyl. This is because we have 3 branches of methyl, that's why the prefix 3, and their locations are in the second carbon and in the fourth carbon. And then, as it is a chain of 6 carbons, there is a prefix of hexane and ane because of alkane. And in this example, there is 2,3,5 trimethyl. This is why we have 3 branches of methyl, and their locations are in carbon number 2, carbon number 3, and carbon number 5 of the longest chain. And the longest chain has 1, 2, 3, 4, 5, 6, and 7 carbons. That's why the prefix ept and ane because they're alkanes. Okay, now I will teach you what are the steps to draw structural formulas with alkanes. We see here step number 1. Draw the main chain depending on the number stated in the name and numerate them from left to right. Number 2. Add all branches indicated in the name. And number 3. Fill each carbon with its hydrogen atoms. Remember that each carbon can only have 4 bonds. So I have here an example that says 3-ethyl 2,2,5,5 tetramethyl octane. So we start from taking octane, that is the name of our longest chain. So we have to write 8 carbons because the prefix oct. Remember to leave some space between the carbons to put the hydrogen atoms. Then we have to start with our branches. For example, here we have 3 ethyl. So in the third carbon, 1, 2, 3, we put 2 carbons because ethyl is from 2 carbons. Then we have 2,2,5,5. So in the second carbon, it says that we have 2 methyls, 1 here and 1 here. We know this because there are 2 number 2s, and then in the 1, 2, 3, 4, 5, in carbon number 5, we have 2 other methyls, 1 here and 1 here. And then we just have to fill with the hydrogen atoms. Remember that a carbon can have just 4 bonds, so this is how we know how many hydrogens we have to put. And that's it. This is how we draw structural formulas. Okay, now let's see 2 more examples. I have here 4-ethyl 3,4 dimethyl octane. So we have to start from octane, and we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. Then we start with our branches. In the carbon number 4, we have our branch ethyl. 1, 2, 3, 4. We have here our ethyl. Then in location in the carbon number 3, we have methyl. 1, 2, 3. And in carbon number 4, we also have a methyl here. And then we just fill with hydrogen atoms. Then here And now we have this one that says non-name, and thanks to the prefix non, we know that they are 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. Then we start with our branches that are 4 and 5. 1, 2, 3, 4. We have ethyl here, and then in 5 we have another ethyl. Then in the carbon number 2 we have 2 methyls that are here. And that's it. Okay, and now let's see alkenes. Alkenes, we have to remember that are identified by having double bonds. The steps for naming are: number 1, find the chain of carbons, but we have to remember that the chain must include the double bonds. Step number 2, circle the branches. Step number 3, number the carbons of the main chain. Step number 4, name the branches. Step number 5, start writing with the location and name of the branches. And step number 6, name the longest chain. And we have 3 steps here. That is letter A, prefix by amount of carbons. Letter B, location of double bonds. And letter C, the ending. Okay, and now let's practice with this example. Our first step is find the chain of carbons. We have to find the longest chain of carbons, but it must include the double bonds. So we start counting. 1, 2, 3, 4, 5, 6, 7. Or we could have 1, 2, 3, 4, 5, 6, 7, 8. Or we could have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or we also could have 1, 2, 3, 4, 5, 6, 7, 8, 9. So as it is our longest chain, we'll circle it. Remember that our longest chain must be continuous so that it doesn't have more extremities. Now let's go with the second step, is circle the branches. We circle our branches. Okay, then number the carbons of the main chain. Remember that for numbering we have to start from the nearest branch it is. So this branch is 1, 2, 3 in the third carbon, and 1, 2, this is in the second carbon. So we will start counting from here. Okay, we have our 9 carbons. Then we have to name our branches. This, as it has just 1 carbon, it is a methyl. Just like this one and this one. But as this has 2 carbons, we will name it with ethyl. Okay, then we have to start writing with the location and name of our branches. We start. Remember that we have to start by the alphabetical order, so we have from E, and its location is in the 5th carbon. So now we have to put our other branches, but remember that we have, so if we have 3 same branches, we put them we just number the location just like this. Two comma, because this one is in the 2nd carbon, then 3rd, and in the 7th. And now we have to specify that they are 3 branches, so we put the prefix 3 and the name methyl. Then we have to start with the name of the longest chain. And first we have to put the prefix by amount of carbons. So we put the prefix by amount of carbons, so as they are named carbons, we put none. Then in letter B we have to put the location of double bonds. This is important because we have to specify where the double bonds are located. So they are in carbon number 4 and in carbon number 6. And now we end with our ending depending if it is alkane, alkene or alkyne. And this is an alkene. So this will be our name. Okay, now let's see two more examples. Here I have 3,3 dimethyl. This is because our branches are in the third carbon, and D is because the prefix, because they are 2. Remember that in alkenes and alkynes we start numbering depending on where the double or triple bond is nearest. Then but because they are 1, 2, 3, 4 carbons in our longest chain. 1 because it is the carbon with it is the double bond, and in because it is an alkene. Then we have here 4 ethyl. It is because 1, 2, 3, 4 we have in the location 4 our branch of ethyl. Then we have 2, 1, 2 methyl. And then this X 1, 2, 3, 4, 5, 6 because there are 6 carbons in our longest chain. 1 because in the first carbon there is the double bond, and N because this is an alkene. Remember that we start naming the branches alphabetically. Okay, now let's see how to draw structural formulas with alkenes. The steps are: number 1, draw the main chain according to the number of carbons and the location of double bonds. Number 2, add the branches indicated in the name. And number 3, fill the main chain with its corresponding hydrogen atoms. So I have this example here. Let's see. First, we have our prefix hepta that says that we have 7 carbons. Let's draw them. Now, in alkenes, we need to check the location of the double bonds, and we have them here in carbon number 1 and carbon number 5. One here, 1, 2, 3, 4, 5, and other here. Now, let's go with the branches. In the carbon number 2, we just have 1 methyl here. Now, to finish, we have to fill with hydrogen atoms. Remember that a carbon can have just 3 bonds. And now let's see 2 more examples. Here it says 3-methyl X2-in. Well, now first X, we know that there are 1, 2, 3, 4, 5, and 6 carbons. And the double bond is in the second carbon. Here, 1, 2. Then we have our first branch in the third carbon, that is a methyl. 1, 2, 3, and a methyl. And then we just fill with hydrogen atoms. Then we have this one here that says hexa, so we know that they are 1, 2, 3, 4, 5, and 6 carbons. And then we know here that in carbon number 1, carbon number 3, and carbon number 5, we have our double bonds. Here, 1, 2, 3, 4, and 5. And this is how we draw structural formulas with alkenes. Okay, now we will start with alkynes. Remember that alkynes are identified by having triple bonds. The steps for naming are just as the alkenes. Number 1. Find the chain of carbons. Must include the triple bonds. Number 2. Circle the branches. Number 3. Number the carbons of the main chain. Number 4. Name the branches. Number 5. Start writing with the location and name of the branches. Number 6. Name the longest chain. And as alkenes, we have 3 steps. There are A. Prefix by amount of carbons. B. Location of triple bonds. And C. Ending. Now let's practice with this example. Okay, our first step is find the chain of carbons. Now we have 1, 2, 3, 4, 5, 6, 7. So I think that it is the longest. And remember, alkenes and alkynes, in our longest chain we must include the triple or double bonds. Step number 2. Circle the branches. Step number 3. Number the carbons of the main chain. Remember that we have to start from where the double or the triple bond is nearest to a side. And 7 carbons. Now number 4, name the branches. You have to name our branches. Now start writing with the location and name of the branches. We will start with the location of our branches. There is in the 3rd carbon, but whoops. We have to specify the location of both of them, and then we have to specify that they are 2. So we use the prefix T, then methyl. And now, as we don't have other branches, name the longest chain. We start with the prefix by amount of carbons. So, as there are 7 carbons, we will use ept. Then we have to specify the location of the triple bonds. That is in carbon number 1 and in carbon number 4. Then we finish with the ending, that is alkyne. So we finish with D because they are 2, ein. And this is our name. Okay, now let's see 2 more examples. Here, for example, I have 5 ethyl because in the 5th carbon I have my branch ethyl. Then 2 methyl because in the 2nd carbon I have my branch methyl. Then ept because they are 7 carbons in the longest chain. 3 because this is the carbon in which the triple bond is located, and ein because this is the ending of alkynes. Then here 2, 5 dimethyl because this is the location of our branches, 2 in the 2nd and 5th carbon, and they are 2, that's why the prefix D. Then ept because they are 7 carbons, and the triple bond is located in the 3rd carbon, and the ending of alkynes are ein. Now let's see how to draw structural formulas with alkynes. Okay, the steps are: step number 1. Draw the main chain according to the number of carbons and the location of triple bonds. Step number 2. Add the branches indicated in the name. Step number 3. Fill the main chain with its corresponding hydrogen atoms. Now I have here an example that says 4 methyl penta 2 ein. So as here it says penta, we know that they are 5 carbons. Now, thanks to this number, we know that the triple bond is in our second carbon. So 1, 2, here and here. Then our branch is a methyl in the fourth carbon. 1, 2, 3, and 4. Here is a methyl. Now we just have to fill with hydrogen atoms. Remember that carbon can have just 4 bonds. Okay, and now let's see 2 more examples. Here it says 5-ethyl 2-methyl hepta 3-ine. So thanks to the prefix hepta, we know that 1, 2, 3, 4, 5, 6, 7, they are 7 carbons. Then thanks to this 3 number, we know that 1, 2, 3, in the third carbon there is a triple bond. And now we go to our branches. In the carbon number 5, 1, 2, 3, 4, and 5, we have an ethyl. There it is, our branch ethyl. And in the carbon number 2, 1, 2, we have our branch methyl. Here it is. And now in this example we have but 1-ine. So thanks to the prefix but, we know that there are 1, 2, 3, 4 carbons. And thanks to the number 1, we know that the triple bond is in the first carbon. So this is it.
Okay, now let's get started with aromatics. How to name them according to UPAC nomenclature. Okay, first of all, in all aromatics you will find this 6-side figure that is called benzene. Always gonna be called benzene. And you will find substituents from its coming from the 4 carbons. In this case we have chloride, which prefix is chloro. So because we only have 1, we won't add a number with comma or hyphens. You will only write chloro and benzene. So it's pretty easy if you only have 1 branch of substituent in order to name it. Okay, now that's if you have 1 substituent. But now if you have more than 1, for example, if you have 1 here or here or here, okay, first of all, you will use the prefix ortho before naming the substituent when you have the 2 substituents in number 1 and number 2. That will be ortho because it comes from the Greek for 2. Then metha if you have the substituents placed in number 1 and number 3. You will use metha before naming as a prefix before naming the substituent. And para if you have the substituents in number 1 and number 4. Let's make one example. Okay, now if we have in a benzene with 1 propyl and another propyl, one placed in number 1 and number 3, we will use the prefix metha. So we write metha hyphen, we have 2 propyls, dipropyl, and benzene. When we use this type of prefix, we don't need to write 1, 3. No, metha is the one that substitutes the numbers. Meta, hyphen, dipropyl, benzene. That will be the name. So I hope this really helped you. So let's review the steps in order to name cycloalkanes according to UPAC nomenclature. First of all, let's start with the steps. When numbering the carbons of a cycloalkane, start with a substituted carbon because they have the lowest numbers. Number 2. When 2 or more substituents are present, number according to alphabetical order. Number 3. Observe the branches. Cite the alkyl substituent before the name of the parent hydrocarbon. Number 4. If the same alkyl group occurs more than once as a branch on the parent structure, use a prefix before its name to indicate how many times it appears. Number 5. Write the entire name using hyphens to separate numbers from words and commas to separate numbers. Add the prefix cyclo to the parent hydrocarbon's name. Now let's practice. Okay, here we have a cycloalkane with 5 sides. So that will be a cyclopentane. But first, in order to start numbering, you need to start from the branches that have in alphabetical order. So here we have 2 methyls and we have a propyl. So we will start with the 2 methyls. So we will write 1, 1 because we have 2 methyls, hyphen, the prefix D because we have 2, methyl, hyphen,
3, we only have one propyl, so we only write 1, 3, hyphen propyl, our prefix cyclo, and then the name of our parent chain, which is pentane. So it will be 1, 1 hyphen dimethyl hyphen 3 hyphen propyl cyclopentane. Okay, now let's review another example. Here we have a cycloalkane of 6 sides, and it has only one substituent, which is a methyl. When you have cycloalkanes with only one substituent, you don't need to number the cycloalkane. So for example, here we have one methyl, but because we have only one, we will only write methyl, then the prefix cycle, count the number of sides you have, which are 6, so the prefix will be X, and then because we only have single bonds, it will be hexane. So the name will be methyl cyclohexane. Okay, finally, let's review one more example. Okay, here we have a cycloalkane of 1, 2, 3, 4 sides. So, okay, let's review a final example on cycloalkanes. Here you have a cycloalkane of 1, 2, 3, 4 sides. So, it will be butane, cyclobutane. Now, we have a methyl here and a methyl here. So we write 1, 3, our prefix D because there are 2, methyl, no hyphen or comma, and then cyclobutane. So it's pretty easy to name cycloalkanes. I hope this helps.
Hydrocarbon deliveries by definition must contain one or more atoms of some other element than carbon and hydrogen. These additional atoms are called heteroatoms. A heteroatom is an atom other than carbon or hydrogen presenting a hydrocarbon delivery.